Hi everyone, welcome back to our channel. Today we're diving into an important topic for anyone working with Google Cloud. I am in GCP and IAM best practices. So let's get started. First, let's talk about Identity and Access Management, or IAM. IAM is like the security system for your cloud environment. It controls who can do what on which resources. Think of it like the security system in a building that manages who can enter which rooms and what they can do there. IAM manages different types of identities. These are users, like a developer or admin, service accounts used by applications, or Google Groups, collections of users. Imagine a school. Identities are the students, teachers, and staff who need access to different parts of the school building. In the digital world, identities can be users, like you and me, applications, or even other services. So, identities are entities that interact with Google Cloud resources. Google accounts are individual user accounts that are used to authenticate and authorize users accessing Google services, including Google Cloud Platform, GCP, typically used by individuals such as developers or administrators. Imagine you are a developer named Jane. You have a Google account with the email address jane@gmail.com. Using this account, you log into the Google Cloud Console to manage your projects, create virtual machines, and deploy applications. Service accounts are special Google accounts intended for use by applications and virtual machines, rather than individual users. They allow automated access to Google Cloud resources, used by applications or virtual machines to perform tasks, allowing for automated and controlled access to resources. Suppose you have a web application running on Google Cloud. Instead of using a personal Google account to access the database, you create a service account specifically for the application. This service account, named App Service Account in my project.imgserviceaccount.com, has permissions to read and write to the database, allowing your application to function autonomously and securely. Cloud Identity is a Google service that provides identity management for users who do not have a traditional Google account or G Suite account. It enables organizations to create and manage user identities. For organizations without Google accounts, providing a separate identity system. Consider a company that does not use Google Workspace, formerly G Suite, but still needs to manage employee access to Google Cloud resources. The company can use Cloud Identity to create and manage user accounts for its employees. For instance, John, an employee, is given a Cloud Identity account, johnacompany.com, that allows him to log into the Google Cloud Console and access the necessary resources based on his assigned roles. In IAM, we deal with resources, permissions, and roles. Resources are entities within Google Cloud that can be managed and interacted with. They are the building blocks of your cloud environment. Cloud storage buckets are the storage locations for your data. Pub subtopics are the messaging services for building event-driven systems. App Engine applications are the managed platform for building scalable web applications. These are all examples of the resources. Imagine you are building an e-commerce website on Google Cloud. Your project includes several resources: a virtual machine running your web server, a cloud storage bucket for storing product images, a pub subtopic for handling order notifications, a BigQuery dataset for analyzing sales data. Permissions are specific actions that can be performed on a resource. They define what operations are allowed. For example, permissions like compute instances, create for creating VM instances, or compute instances, delete for deleting them. Permissions like storage.objects, get for reading data from a bucket, or storage.objects.delete for deleting objects. In your e-commerce project, you want to grant a developer permission to update the web server's code, but not delete the virtual machine. You would assign them the compute instances.update permission, but not the compute instances.delete permission. Roles are collections of permissions that can be assigned to identities, users, groups, or service accounts. They simplify the management of permissions by grouping them into logical sets. Predefined roles, created by Google, offering a specific set of permissions for common use cases. Custom roles, created by users to tailor permissions to specific needs. Allows more granular control than predefined roles. Primitive roles, basic roles that were used in the past but are broader and less secure. In your e-commerce project, you assign the viewer role to a business analyst who needs to see sales data but not change anything. You assign the editor role to a developer who needs to update the web server code and manage the database. You create a custom role for a marketing team member who needs permissions to upload images to the cloud storage bucket, but not delete any existing images. Let's go over some best practices for IAM using some real-life scenarios. Principle of least privilege. Imagine you're the manager of a company. You wouldn't give the janitor access to the financial records. Similarly, only give cloud users the permissions they need. Always grant the minimum permissions necessary for users or service accounts to perform their tasks. This reduces the risk of excessive access that could lead to accidental or intentional misuse. For a developer working on a specific project, instead of granting the editor role, which allows broad access, assign more specific roles like roles compute instance admin if they only need to manage VM instances. Use predefined roles over primitive roles. Instead of giving someone the owner keys to the entire building, give them keys only to the rooms they need. Google Cloud has predefined roles that are more specific and safer. Primitive roles, owner, editor, viewer, are broad and provide more access than necessary. Predefined roles are more specific and aligned with particular tasks. Instead of assigning the editor role to a user, assign predefined roles such as roles storage.objectViewer for viewing storage objects or roles logging, logwriter for writing logs. Regularly review IAM policies. Just like you would review who has access to the building after an employee leaves, regularly check who has what permissions in your cloud environment. Periodically audit and review IAM policies to ensure that they remain appropriate as user roles and organizational needs change. This helps in identifying and revoking unnecessary permissions. Conduct quarterly reviews of IAM policies to ensure that no former employees or redundant service accounts retain access to critical resources. Enable two-factor authentication. Think of this as requiring a key and a password to enter the building. It adds an extra layer of security for accounts. Enhance security by requiring users to provide two forms of authentication before accessing the system. This helps protect accounts even if passwords are compromised. Use groups for access management. Manage permissions by assigning roles to groups instead of individual users. This simplifies permission management, especially in large organizations. Create groups for different teams, e.g., developers, QA, operations, and assign appropriate roles to these groups. Add or remove users from groups as needed. Separate duties and environment access. Ensure that different roles and responsibilities are separated to reduce the risk of fraud or accidental errors. For example, separate access to development and production environments. Developers should have access to development resources but not to production databases. Use IAM policies to enforce this separation. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more updates. And if you have any questions, leave them in the comments below. See you next time.